Tutorial that I'm putting together here is to show how to design a PV system using the Helioscope software in order to make sure the efficiency and design is suitable for a business case. So first thing that we're going to do is we're going to log in. You would naturally have the login details either saved in your computer or they would be with one of your team leaders. So once you get in, you'll notice that there's a whole list of projects that have already been designed. Okay, but we're going to be creating a new project for Vision Business Park. It's going to be a 140 kilowatt PV array with a hybrid solution. So we're going to add 2 battery-based inverters to the solution. I've already been through to site, so I've identified the roof that I want to use, and I'm happy to proceed with the design now. So what we first do is we click on the new project tab. It'll come up. Here we're going to say the specifics about the project. It's 140 kilowatt peak hybrid system for Vision Business Park. This can also be the other way around if you wanted to. You can get creative as you like there. So 5 Totem Road is the address. So once this address comes up here, you need to identify the building. So for example, if you zoomed out quite far, I know that this is the building that I'm going to be using here. So I'm going to zoom in because this is going to be the picture that's going to be on your document once you complete it. So I know I'm going to use this roof here where the panels already are. Right, so the other thing that you can see here, in your profile you get a couple options: residential, ground mount, commercial, international, and then default commercial. We use default commercial unless it's a ground mount system. Click on default. In here we're going to be more specific about the system. So it'll be 150 kilowatt peak on roof PV system with SunSync hybrid HV inverters and Freedom 1 batteries, because this will all be part of the total design description, as I'll show you now. So we click on the create a project. All of that information is now in the overview of the project. Perfect. So you get to this screen over here and it says design. We have design, condition, shading, sharing, and report. Right? We're going to start with design. So you click on design. In the description of the design, you need to put your initials. Okay, I normally put my initials. And then if you want to put anything more for the customer reference, but this is just to say who did the design. Create design. And it's going to take you through to the page where the roof is. So now you can move in and out of the roof. You can move the screen around to allocate it to or position it in a place that you want. The top of the screen is always north. So the first thing that you need to understand is when you were at site, which way were these roofs sloping? What was the pitch of the roof? And which direction are we planning to install these panels on? So in my case, I'm going to face them towards here where it says save and exit. That's my north. So unfortunately the roof is positioned here, so it's slightly off. Now what you need to really look at here, and this is the starting point. If, for example, I had to put these panels on the roof, I'm going to choose this area over here. Right, they naturally start facing north. But we want them perpendicular to the sheeting. So we're going to change a thing called the azimuth. Right, and the azimuth we're going to change, I'm going to guess 30. Okay, 29, play with it, there we go. So that's 29 degrees, facing that way. If I had to decide I wanted to face the panels that way, I would need to increase this to, on the compass, let's have a look. It would have to be roughly 300 degrees. Okay, so this direction that I've got over here is 60 degrees off of north. This one over here is only 30 degrees off of north. Therefore, I'm going to use the 30 degrees off of north option. That's the best option there. Okay, perfect. So that's our orientation. Keep in mind we're trying to aim for a 140 kilowatt system. So already my block isn't too big, but let's go through the requirements of it. So in this, starting from the top here, we need to choose the right solar panel. So we've got some favorites here that we've chosen. I know we always work with the 550 watt panel right now. There it is. So that already picks up more production per square meter. The other thing that we need to decide here, is it going to be an inclined system or a flat packed system? So in this instance here, I'm wanting to do a flat pack system. But in order to not overshoot the square, there's a thing called the setback at the bottom. The setback is to do with this ring around the roof where we say this, we don't want to install that close to the edge. So here I'm going to make the setback 0.8 because I don't need to be so excessive about it. We've got a large roof, but I'm wanting to just display it on the roof nicely. The size of the system is a 126. Let me just play with my azimuth to see if I need to line it up better. No, it was fine. Okay, so that means over here I just need to move my block a little bit. There we go. We're at 132. We can just expand on the roof by dragging these a little bit more. Okay. So now we're at 148. So there is a section at the top where you can say set max kilowatt peak, and you can set this to 141 for example, and it will give you 140.8, and it'll take out those panels that are not needed. Now it's up to you if you want to shuffle this around so that it moves those panels around. If you can see, you're still at 140.3, but now your grid looks a lot better. Perfect. So 140 is what we aimed for. It's Canadian solar panels. The tilt angle 10 degrees is perfect. It's chosen it for this area. They are in landscape because that's how we install them. We don't install them in portrait. And the row spacing is 0.6. You can make row spacing. The minimum that you can go is 0.5. And then module spacing will be the 12 mils, which is the gap between the panels for the mounting structure. So we finished with the panels. We now need to go to keep outs. For example, this over here looks like an obstacle with a keep out. If we were using this portion of the roof, we would put a keep out there. If, for example, there was a keep out over here, it would take panels out of that area and we wouldn't be able to use those panels. You can do keep outs for chimneys, okay? And on that keep out, what you can also do is you can say that the height of it is 6 meters, 7 meters, and that will automatically show you where the shadowing is going to happen from that device. So if there was a big tree, for example, like that, and we knew that that tree over there from the ground was going to be 20 meters. As you can see, it will shade that roof there and we won't be able to put any panels on that section. But in this case, there is no keep outs that we need to consider. The roof is beautiful. Electrically, it'll always start up with the SMA Sunny Boy. That's just its generic go-to. Here's our Grow Watt ones. I am going to put the SunSync in favorites, but for now we use the SunSync. SunSync, just type in SunSync 50. There's only two options. There's a 400 volt and a 380 volt. Ensure that you choose the 380 volt. We are 380 volts in Africa. And because of the oversized, it says that we need 3, but we are going to put 2. Okay. Specifically, we are able to go to 130. So for the purpose of the design, we'll put 3. As you move your inverters around, can you see that the software has already allocated those panels to that PV array? So if your inverter room was going to be, for example, where these cars are, you could move these inverters there and you can see that the solar cables are moving as well. That's going to give us an understanding of the length of the solar cables and also work out any losses involved in the system. Perfect. So now on the advanced, there is a thing called shadowing. You can click on the shadowing and you can say calculate the shadowing. And it's going to show you where you're going to have any shadowing. Here we've got absolutely no shadowing. There is zero shadow loss, 0%. 0.5% if you really push it. But as far as it goes, shadowing looks good. You don't have to ever look at shadowing because you know that you're on top of a building. So far you've got the right inverters, you've got the right panels. You say save and exit. Conditions, you never touch the conditions. This will automatically find the best weather station in that area. Okay, this is where things would go wrong. You don't want to adjust any of these conditions. Shading, once again, you don't want to upload any of the data here. You don't need to do anything. Sharing, same thing, you wouldn't need to do it. The only ones that we work on are design and report. Now in report, you need to click the simulate button. It's going to create the document. If, for example, you just wanted to understand for your business case how much power you could produce, you can click on energy, and this system does 215,400 kilowatt hours per year, or 215.4 megawatts. So you wouldn't typically need to open it to see how much power it can do. So if you wanted to run a simulation between flat packed and inclined on the same roof, we would simply go into design, we would say new, we would say again JSW, right, and we would say clone the design. There it is there. So once you've cloned it, it's going to create, we have to click here, flat packed, create design. It's going to go back into the design software. In this case over here, we're going to make sure that it's not fixed tilt rack, that it's going to be flush mounted. Flush mounted, it automatically creates shadows, therefore you know that you need to have your panels, okay? It's now, because it's flush mounted, it's saying that the roof is 10 degrees. And that roof there is creating that shadow. But we all of a sudden don't want the gaps in the panels like that. So we're going to say that we want something along these lines. So you click frame size. You can either go, or you can go this way like it is. Sorry. It's not doing it. Okay, let's leave it like that, and then we can increase the rows for servicing. So that's the other option. Now we're still at 140 because remember you've set your max. So if you want to remove the max, you'd have to remove it there. Perfect. So now same electrics, everything would be copied, and we're going to say save and exit. Going across to the report section, we've got flat packed and we've got my standard design. We have to push the simulation button. And we're now going to create a design based on a flat packed installation. For some reason it's taking a bit longer than planned. Let's look at the design in the meantime. Going into the design, if you're on Helioscope, there is, let me just try and exit this, still busy. On Helioscope, there's a couple things that you can have a look at on the live version. If you click CSV, it will download an annual prediction on production for this site, which you can give to your customer. Sometimes they want to know what will it do in August. You can show them the CSV. It'll do it hour by hour, day by day for an entire year. If you click PDF, it creates your PDF, which is what you're going to need for your business case. And then the other options that you've got here, you've got the shading report. So in the shading report, it's going to give you a full report based on the site, the level of the shading, the annual production, the reasons. It'll give you sort of simulations. It's trying to do a 3D render here, but it doesn't look like it's done it too well. But if your client wants to know what the shading factor is, you can use that. Other thing in the design over here, if you want to do the monthly production, you can click on the table and you can take this type of information. You can see exactly that one there is 1346. There it is there. That information is here based on these details. So you can, they don't show you in the report, but you can click on this and export it. At the bottom, very important to notice, if you rush to print the PDF and exit, this picture will be blurry. So you'll tell by the logo whether or not it's blurry or not. Okay, so what I'm going to do is I'm going to exit here. I'm just going to refresh this, and I'm going to go click simulate. There we go. Now it's simulating it. Right, so already you can see on the performance, the flat pack is a lot less efficient. On the energy, we're going to produce around about 10,000 kilowatt hours per annum less. So by doing the same equipment, same price, same everything, the client will be using less power. So we're going to be using this one over here, and this system is going to be used for our business case. As I mentioned, wait for the picture to download. There we go, it's loaded, and you can click the PDF, print to PDF. That is how you make a helioscope based on your site.